Let's continue with part 4b, section 4. The zero state and the zero input. We're now at page 24 of our slide. In here, we examine the term complete response again. And the solution of the complete response solution, we would now tell you that actually it is y of zero state plus y of zero input. Let's discuss this term. Now, y of zero state is the response of the system due only to the input with the state condition, internal state condition, to be zero. Means to be relaxed, or the initial condition is zero. Why zero input? Then if you think, if I send a zero input, why should there be any output? Well, there can be output if there is initial conditions. So why zero input examines the system due to the initial condition. Why zero state examines the system due to the input. Alright, so don't get confused here. So let's draw a diagram. Ht represents the impulse response of our system. We take the input. And we know that some systems have initial conditions, given initial conditions of what you call it, of y's, dy dx, and so on and forth. Y at time 0, y prime at time 0, and so on. The complete response that we'll get actually is not only dependent on the input, but it is also dependent on the initial condition. So we actually have to we can calculate them independently. What do I mean? Well, you know that the system is linear, right? And if the system is linear, theoretically, you can examine only the input. You ignore the initial condition. There is no initial condition here. And if you can find out Ht, then there is the yzs. So this guy is this guy. Now, if you send an initial condition into the system and there is no input, we are now going to do it this way. The initial condition, the system, but now we add H1, which is a modification of Ht. You'll see why later on. H1 is some additional function of Ht. Okay, it's not Ht. It can be Ht under certain condition, but it can be slightly different. Now, here is no input, right? We have no xt. We are only driving the system using the initial condition. So we call this the yzi, y0 input. Together they form the complete solution, yt. That's what we are trying to get. Now it is possible because the system is linear. So in example 2, just a few videos ago, you'll see that I have evaluated yt given the causal signal but with zero initial condition. Now we are going to evaluate exactly the same problem but with some change of initial condition, and you will see what needs to be added. Okay, let's go. Okay, but before that, let's have some theory first. What is zero state and what is zero input response? Let's clearly define them. Now, you realize that ODE with constant coefficients are not linear unless the initial conditions are zero. Otherwise, they're not linear. And if the input is not causal, okay? Because if it is if the output is non-zero, but the input is zero, why is this possible? When there are initial conditions. So you have to be very careful here. Now, when the input is causal, there's still the initial condition that can cause some problems. Okay, so we can think of initial condition as additional inputs. So finally, we are going to calculate it this way. We are going to treat each of them independently to get these two things. That's the idea. But why do we want to do that? Well, sometimes is if you change the initial condition, if you have already calculated this, then what happens is that you only need to change this. If this is changed, this is going to change, 0 input. If this is changing, if xt is changing, then this guy is changing, the 0 state. So if we are clever enough to work each one of them independently, then the only thing that change needs to be updated, and we can get yt again. Alright. So I told you that when we have xt and the initial condition, we'll get the 0 input and the 0 state. And this top part have the same ht. When we send xt in, remember when we send xt in and we convolve with ht, then this must be a 0 state response, because ht must be relaxed. Okay, but what about this guy? Why did I write h1 of t and not ht? Let's now see why. In this particular second branch, there's no real input. It's the initial condition that is driving the system, and out comes some response. We call it the 0 input response. Okay, let's try. Let's have a second order equation for y. So we have a2 y2 means second derivative of y, a1 y1 first derivative of y, a0 y0, and so on. On the left hand side, on the right hand side, let's have a simple first order, x1 of t, x0 of t, and we are going to take the Laplace transform. So here we must remember to keep all the initial conditions. So these are all the initial conditions. They are non-zero. I mean, if they are 0, then the system is relaxed again. Then but there is no what do you call it, y0 input, because if all these are 0, then there's no response due to the initial condition. Okay, let's look at all these 3 red boxes and collect them. Let's also take the green boxes and collect them. So all those guys with the y's are here. And all those guys with the x are here. And we collect the x, we collect the y, and we collect the due to the initial conditions. So the red guys are the initial conditions. The green guys are due to the input, and the output, the derivatives. Alright, you collect all of them together. Let's call this AS. Let's call this BS. So we have YS AS, XS BS. Let's collect all the red box. Let's call this IS. So it's this guy plus this guy. Now we are almost in a position to then so the AS is due to YS. We can bring it to the other hand side, so it becomes the denominator. So now you see that this part is due to the input. This part is due to the initial conditions of y and x. This guy is h of s. because h of s is bs over as. But this is is over as. It's not bs over as. So that is why we call this h1, the zero input impulse response. This guy on the left is the zero state impulse response. Zero state impulse response is the real response, the real impulse response of the system. The zero input impulse response is due to the initial condition. That's why it's h1 of s. Alright, so now we figure out why ht and h1 of t. So this is again the same description. I'll not go through. And finally, I'm going to use example 3 now. But that we'll leave it for the next video. In example 3, we're going to do everything the same as example 2, the same xt, but with now initial conditions. Thank you.